If we're going to find the accumulation function for the integral from 0 to x of 6t squared minus 2t dt, all we have to do is actually integrate this. So the integral of 6t squared, that means we're going to increase the power by 1 and then take 6 divided by that power. And then the power of t is 1, so we'll increase that to 2 and take 2 and divide it by 2. So there's our coefficient. And we're going to evaluate this from 0 to x. So just plugging things in. First I'll plug in x, 2x to the third minus x squared. And then I'll plug in 0. 2 times 0 to the third minus 0 squared, which of course is 0. And we're left with 2x cubed minus x squared. So our accumulation function, b f of x, is equal to 2x to the third minus x squared. If we're going to find the accumulation function for cosine, again, we just take the integral. And the integral of cosine is sine. And we'll evaluate this from 0 to x. So first we'll plug in x, and then we'll plug in 0. The sine of 0 is 0, so this thing simplifies down just to sine of x, which means our accumulation function, if we want it to be different maybe than f of x, we'll call it g of x, is sine of x. Now pay attention to the details, because not every time are we integrating from 0 to x. In this case, we're integrating from 1 to x for 1 over t plus 4e to the t dt. But our plan is still the same, to actually integrate it. And the integral of 1 over t is going to be the natural log of t. And the integral of e to the t is e to the t. And we'll evaluate this from 1 to x. So first, plug in x, natural log of x, plus 4 e to the x. And then we'll plug in 1, natural log of 1, plus 4 e to the 1. Simplifying, everything that has an x in it continues to have an x in it. There's nothing to do to simplify that. But natural log of 1 is 0, and 4 e to the first is just 4e. That means that our accumulation function, maybe I'd call it k of x, is natural log of x plus 4 e to the x minus 4e.